Hi everyone, myself Merin. Today I am going to present a topic on dampers in retaining wall, that is cantilever retaining wall. The contents included in my presentation is first of all introduction and the dampers and the various type of dampers, retaining wall and the retaining walls types and the working procedure of dampers in cantilever retaining wall and how I design the research and the conclusion, the reference. And the introduction part is include that due to the devastating earthquake or some other natural calamities like landslides and all, the number of deaths in the countries are increased due to the fall of structures. Main reason is due to the seismic assaults towards the structure. And to prevent this seismic assaults or such variations in structures due to the assaults, the energy absorbing devices are introduced. Some of the energy absorbing devices are dampers, porous fiber metals, fluid recentering devices and etc. Mainly the dampers are used to control the seismic effect on the structures. And the most commonly used energy absorbing device is dampers. Dampers are of different types. They are metallic dampers, friction dampers, tuned mass dampers, tuned liquid mass dampers, elastoplastic dampers and X-plate dampers, etc. And metallic dampers, viscous dampers and friction dampers are most commonly used to avoid the seismic vibration towards the structure. And coming to the part of metallic dampers. Metallic dampers are mostly used on bridges and base isolated buildings. And about the viscous damper, they works on the principle of rapid flow through the office, and they are mostly applied in 3-storied buildings. And the friction dampers, they are used in single stored steel frames and other structures. This picture shows the metallic damper, and this is a typical picture showing friction damper as well as viscous damper used for the controlling of the seismic vibration. This next part is retaining wall. What is meant by retaining wall? The retaining wall are the structure constructed to resist the lateral pressure arise from the base of the loose soil due to the changes occurred in the ground elevation, and is also constructed to provide the building from the soil erosion, and it may be used in the canals also, and in dams all are used by retaining wall to control it from the soil erosions and various other changes. And it's constructed with a maximum slope, and there are of 5 types. There are gravity retaining wall, cantilever retaining wall, sheet piling retaining wall, and board pile sheet retaining wall, and anchor retaining wall. And quick survey to the types of retaining wall. They are the picture showing the retaining walls. It's gravity retaining wall. It's already mainly it's withstand by its own weight, and relatively easily, and internal leverage of earth pressure is very high. Earth pressure is very high in the gravity wall. And about the piling wall, its piles themselves can resist the bending of the retaining wall. And the cantilever has the lever arm to support the wall, and it also can withstand some of the pressures and all, and it will stabilize the earth pressure on the wall. And the anchor wall is fixed by expanding anchors. Next, moving to the working procedure of my research on viscous dampers in cantilever retaining wall. Actually, the ordinary wall loads are similar to the retaining wall. The loads acting on the wall are mostly similar, like live loads, swing loads are similar to the retaining wall. I think in my opinion, in my research, the dampers using in the wall can be also preferred to the retaining wall. It also may be effective to avoid the seismic effect on the retaining wall. Actually, viscous dampers are mainly used in ordinary wall. The same dampers can be applied in the retaining wall, and it works on the principle of rapid passage of fluid through the orifice, as we say earlier. And the dampers installed in the different location of the retaining wall to detect the deflections as well as any changes occurring on the retaining wall when external force acts on it. And the dampers starts to detect all the loads, and with the help of the software or other computer media, we can calculate the longitudinal displacement, vertical displacement, shrinkage effects, and thermal expansion and slope variations, and also the contraction of the structure can be estimated. This is the typical picture, shows how the viscous damper is applied or connected in a retaining wall. This is the picture showing in the ordinary wall, and this is the same way we can apply it in the retaining wall. And from these following calculations, we can estimate the graph. From those graphs and tables, by method of time steps and precise analysis, it can be done to determine the proper unit of to avoid the building from structure from the seismic hazards. And it also dissipates the energy capacity and specifications to avoid the retaining wall from the seismic hazards. Next is the research design. How I did my research. The way I did the research is by mixed method of design. Actually, it is a multiple way of designing. It includes the quantitative and qualitative research. And my research was done by two phases. In my first phases, it includes the collection of data from external source, like journals, by internet source, and from the source, and all the information from our lecture notes and lecture slides, how to write the essays note. And the second phase of my research include the study of experiment and the journals to avoid the risk and to increase the accuracy of my research. And the conclusion is, the viscous dampers in retaining wall will be more effective and rapid when compared to other technologies, and can be gives a predictable reduction in both stress and the deflection of wall structure. And despite the analyzing consideration, installation methods and developments in the progress. And it can be designed to, it can also be applied to the retaining walls in gardens, vans, etc. And furthermore, research can be improved the special types of dampers in retaining wall. These all are my references, and thank you.